Welcome to this lesson on the financial payment method. After completing this lesson, you will be able to calculate a periodic payment using the financial payment method, leverage any pre-existing knowledge you have of Excel to jumpstart your work with financial functions in Visual Basic. Let's explore a very useful and frequently used function in the .NET Framework financial function libraries, and that is the payment function. And let's approach this in our learning by scaffolding our learning based on something that's already familiar to us. And so many of you may already have a lot of experience with Excel, and some students may be real Excel jockeys. And it turns out that most of the financial functions that will run across the .NET framework have very similar or identical cousins over in Excel. And so using these functions can be very familiar. Also, Excel has a really excellent function wizard to help you build and get familiar with these functions and understand them. And so since that's not built into the same degree in VB, it can be useful to use Excel in order to enable our learning of these functions in VB. Now I'm going to show you the payment function, which is used to calculate the payment on a consumer loan of some number of payments over some period of time at a given interest rate. But based on what we're learning here, you'll be able to take the same approach to explore and master a lot of the different financial functions and indeed some of the other numeric and statistical functions that you'll find supported in VB and its libraries. So with that in mind, let me start in a spreadsheet. So yes, you are still in a VB programming class, even though we're looking at the Excel spreadsheet. And let's go ahead and model a little loan calculator. And let's adjust our columns a little bit. And so here I've got a column for APR in the annual percentage rate percentage. Monthly payments, loan amount is going to be, I've set it initial $12,000. You can change that. Term in years is going to be 5. You can change that as well. And then let's do this as well. Let's set up the model for the interest rate over a range of interest rates. We may not know right up front from the bank what we're going to qualify for, what interest rate they're going to offer us on the loan. So we'll kind of have in mind what the range of payments will be based on these. We'll calculate them all. Let's see. Let's go ahead and make this a little prettier, which we wouldn't have to worry about formatting. Well, we would format the controls and things in VB and format our outputs. We'll explore that a little bit, but it's a little different formatting a spreadsheet. So that part of the knowledge won't transfer quite as completely. All right, and let's see, that's already set as percentages, and we'll set this to be formatted for currency. All right, so we've got what we need to start with. We know the amount of the loan, the term of the loan, 5 years, and we also know sort of implicitly that car payments are made monthly. So even though the term is 5 years, we're going to make 12 payments per annual period. So that's 5 times 12 is 60. And then we need to build our payment function. If you're totally unfamiliar with the payment function, you can, of course, use the function builder and look up payment and use the function wizard to help you build this. Okay, so our rate here is going to be based on the 3%, and of course that's going to be divided over a period of 12 payments. So if it was, the example here is if it was a 6% loan with quarterly payments, we'd say 6% by 4. This is going to be 3% APR over 12 payments per year. Okay. And then N per is the total number of payments. Well, that's going to be the number of years times how many payments per year is going to be 12. And then let's see here, the present value is going to be the amount we're borrowing is $12,000. And we can leave the future value and the type blank. Future value, if you leave it blank, will go to 0, and type just says, are you paying at the beginning of the period or at the end of the period? Customarily, we let interest accrue, maybe unwisely, and pay at the end of the period, sort of in arrears. So let's go ahead and say OK. And notice, since this is a loan payment, it's a you're debiting a credit account, as it were. So if it bothers you that that's a negative number, we can make that minus up here, and that will change it into a positive number. And then we can essentially copy this formula down through the rest of the range. However, since I'm referencing the relative position here, but the absolute position here, so I'm not copying 12,000 down through all these or 5 through all of these. Let's go ahead and make a small change in the spreadsheet calculation, and we're going to make this an absolute reference so it doesn't change as the formula is copied. If you didn't know that trick, we just add dollar signs in ahead of it. And then let's see, the principal amount, the amount being borrowed, is also not going to change. Great. And now when we copy that down, we have our loan calculator. Nifty. Okay. So the loan amount, if we change it, make it $15,000, will update, or back to $12,000, that will update our payments. Also, if we collapse the term of the loan, if you wanted to pay for that in only 3 years, then your payments would, of course, go up. Spread it back to 60 months, 5 years, and the payments go down. We just end up paying more in interest over that period. And there's another financial formula, another function that we can use to determine how much interest we're paying, and that would be also something that would be interesting to explore. All right, so the main thing we want to recognize here, though, is looking at this formula. We have the payment function. We made it negative because, again, payments are always a negative amount. We're debiting a credit account, opposite what you would do if you're making a deposit in the bank, in your savings account. You would be crediting a debit account. For your accounting majors there. The rest of us mere mortals will take it on faith. But putting a negative sign makes that look like a positive amount, which tends to make more sense to regular mortals. And we have this in Excel. All right, let's slide Excel aside for a moment and look at how we might explore this in our code. And here I have the application basically already built, and we can just explore it. So I put a text box in where you can enter the loan amount, $12,000 or whatever. I've got a list box pre-populated with our items collection 2, 3, 4, 5, so you can pick between 2 and 5 years. And then I've got a list box here where we can add items as the payment is calculated. And we can throw that into a loop. Why a loop? Oh yeah, a for next loop would be our counted loop. If we count from 3 to 6% in 0.5 step increments, that will give us what we need here, even maybe a little easier or more convenient than Excel can do it. Okay, so that's what we're going to do. Let's, before we run this, let me show you one other nifty thing here. If you haven't explored the immediate window here before, let's go ahead and I'm going to break the code. So the program is running, but I've broken the code, meaning that I've simply interrupted the code. And one of the things that we can do is in the immediate window, we can give commands. So question mark is shorthand for print. So if I say print hello, then it prints the message hello. Well, this is also a great way to explore some of the functions that are built in to VB or in the VB libraries that can be included in a pretty nifty way. So one of the things that I can do here is I can come in and type this statement. Question mark again means print. Negative payment of 0.03, so that's 3% divided by 12 over 60. That's 5 times 12 monthly payments. So 60 monthly payments and $12,000. And that says 215.62 and some fractional cents. Does that look like what we had here? 215 and 62, and again, the fractional cents are just not being displayed here because we've formatted for currency. But if we were to change that and expand that, you would see that those numbers match in the calculation. So neat. Okay. So yes, this is the same. Let's go take a look at how we develop our code and build our logic in for this then. So let's come back and take a look, and all the magic is in the calc button. I don't think I've changed anything here on any of the properties for these two list boxes or for this text box. It's all pretty straightforward. So let's look at what's in the calc button. Okay. So I've declared my variables, done my housekeeping. So loan amount, I've allowed that to be a decimal amount in case if it's an odd number of dollars and cents. The loan term I've taken as an integer, and I'm assuming that we're only allowing whole year entry and not fractional year entry. So that's going to be an integer. And then I've created a text string for the payment text because we're going to do some formatting on that. I'm not even going to bother to save the intermediate numbers in there. We'll just convert the whole mess into a string, and we'll add that text to our list box as we calculate each item. And the thing it's going to be is it's going to be the current percentage, and then a space and a colon, and then the actual amount of the payment. And then the other thing we're going to need a variable for is the rate, the percentage rate of the loan. And again, I've made that a decimal since that is going to be a percentage. There's very likely to be, well, there's going to be in this case, a fractional component to it. All right, so the first thing I need to do is get stuff out of the user entry on the interface. So I'm using a decimal triparse, and I'm going to try and convert text loan amount dot text into the loan amount. Same thing on integer triparse to read the loan term. Okay, and then I have my handy counted loop, my for next loop. And we're going to say for rate equals 0.3. Aha! All of our examples till now have probably been on the for next loop have been in integers, for I equals 1 to 10 or 0 to 5, that kind of stuff. There's no reason that we can't say in a for next loop that the step is going to be in fractional amounts and over fractional values. So for our rate is 0.3 to a final rate of, or 0.03 to 0.06, and we're going to step in increments of 0.005, which if you multiply that by 100 to get the percent, that's 0.5%. So 3% to 6% in half% increments. And here we're going to say my payment text string is going to be, take my rate, I'm going to turn it to a string. So this is just formatting, no calculation. P1 says it's going to be in percentage format with one decimal place, and then concatenate that and put a couple spaces after it. And then, here's the magic. Recognize that? That's the function we just played around with. And I notice in my version of Visual Studio, I am not having to qualify the financial namespace, the financial library. Seems to be in my native namespace. Your setup may be different, particularly if you're using a little bit older or different version of Visual Studio, in which case you might need to fully qualify it that way. Notice that it's not recognizing my financial namespace, so I don't need to use that. I just use payment, and then here are our parameters. And again, this is where using Excel to try and understand that can be so very helpful. and understanding why those funky numbers are the funky numbers there. You would think that the rate would just be the rate and the term would be just the term, but remember the rate is per period for purposes of compounding the interest. So it's rate and it's how many payments during the period. It's a period of years, so it's because annual percentage rate, so that's 12. So we divide it over 12. The loan term is maybe given in years, but we really pay it in months. So we take the number of years times 12 to get the number of months. And then the loan amount is just the loan amount. And here I'm throwing that, casting it to a string value as currency with the default number of decimal places, which in the US would be 2 decimal places. I could also force that if I wanted a specific number of decimal places, but I don't need to do that. Okay. Having gotten this text string, I am then using the add method that we learned in our handy list box tutorial, and I'm taking the payments list box, and to the items collection, I am adding that string that we just built, and there you have it. So let's see how that runs. All right, so a loan amount of 12,000 over 5 years, and let's calculate that. And sanity check, does that seem to agree with what our spreadsheet said? Yes, exactly. So wonderful. And again, we can recalculate that, change the loan amount, and we could change the term. Oh, you know what I'm not doing? See how this list is getting longer and longer and longer? So what we probably ought to do is, first thing when we come in here, let's clear that text box. So right when we start off, let's take the, not text box, the list box, right? Let's take the payments and list box and clear it. Let's see, not clear selected, so, oh, it's the collection we want to clear. There we go. And let's see if that works a little bit better. 12,000 and calc and 4,000 and calc. Good. Now we're seeing the changes. They were getting stuck on the in and I wasn't scrolling down before. We don't really want to scroll down. It's confusing to have results from multiple runs. So this is what we want. And now we're getting the results we would like to have. All right, so lots of room for improvements here. There's some things, if you're astute and watching what's going on, there's still an opportunity to make lots of errors. So even though I have triparse to make sure that any individual entry is valid, I haven't protected against things like this. Triparse here does nothing, but I didn't detect or do something about that. So if I say calc, now let's see, 0 is okay. Let's run it from the beginning. And notice that no loan term is yet selected. We calc that, and right away we get a crash. And so some of the things we might want to do to improve the program is let's go ahead and set one of these as the default loan term. Okay, so a good place to do that would be in form.load. Oh, let's stop the run. Go into the form.load and let's say the list box payments. No, it's not payments. List box term. And let's go into the items dot and let's select the excuse me. So let's go ahead and set the currently selected item on the list box for the term to the third index item. So let's take a look at the design. So this is the 2 is the 0 item, 3 is the 1 item, 4 is the 2 item. So the third item will be the number 5. And we're selecting that by the index, probably the easiest way to do that. And so let's see what happens when we do that. All right, so now notice that we have something selected by default here. The 5 is selected, and even if we leave the term blank or the loan amount blank, at least we will get a reasonable result rather than having an error and crashing it. Okay, and since we've left this with one select, I can't select nothing uh, in any way that I know of anyway. Yeah, so we will always have at least one thing selected here. And if we do put in the loan amount, we get good results. All right, I'll leave additional improvements for you. And please go ahead and explore the financial payment function. And I also encourage you to use these techniques and scaffold your learning of Excel into some mastery of programming the financial and related functions for VB as well. This concludes the lesson.